it's recording, but it should be. At least we need to. Yeah, it's blinking, so then it's recording, which means that you will have the opportunity to see the lecture on a YouTube video after the lecture, which can be used as repetition and also could be an alternative if you cannot attend a lecture. Links to the lecture can be found from the college webpage, the himolde.no. You can try to find it. This is the main web page, and if you scroll down here, you can find, should find somewhere. Here is the first web page, and if you scroll down here, you will find the himolde X link, and you can now go into logistics and choose this particular course, LOG502, and after the lectures there will be a video, a link to a YouTube video from that particular lecture. So this is an option for you as repetition, and also an alternative if you cannot attend a lecture. Today I will start with some information, presentation of the course. I will also start with the first lecture note, which has been uploaded in Fronter, regarding introduction to what we call the induction proof, some kind of mathematical proofs that can be used to prove whether a formula is correct or not. And also, hopefully, I will start on the first topic from the textbook, which is regarding forecasting methods. Try to find out in an industry or a company or a shop, what is the forecast, how much can you expect to sell for the next periods, which is of course very important for planning the future and the strategies for the companies. The curriculum of this course is also based on some content of other courses, which means that you should have some basic knowledge of logistics, mainly from those of you who come from the bachelor studies here in Molde should have been through either the old LOG300 course or the current SCM, Supply Chain Management 200 course, which is an introduction course to logistics and supply chain management. If you don't have that particular courses, some of you might be international students which have other courses from your own universities. At least there should be possible to get the basic ideas and the basic knowledge of the logistics in behalf. So there will be in this course some overlap with the course BUC 350, the Operation Analysis course here in Molde, with respect to the topics of what we call the linear programming and also some forecasting methods. I know several of you will take both courses, but some of you don't. This is a central part of the curriculum in both courses. There might be some kind of different point of view, but as mentioned, there could be that there are some overlap, and also might be repetition from the other course, either in this course or in the BUC 350 Operation Analysis course. Just if you know the content and take it as a repetition. Also, you need to have or get some general knowledge of mathematics. For example, the introduction course, the Math 100 course here in Molde. And also you should have or get some knowledge of the use of spreadsheet, in particular Excel, which I will use as examples in some of the problem solving here in this course. Most of you hopefully know about the Fronter system. Those of you who don't should try to learn it as soon as possible, because information will be uploaded and published in this Fronter system. And this is the Fronter room. This is a virtual room for this course, LOG502, and the first message here well, this is the Norwegian version, which says the Norwegian Meldinger. You can choose the language of the room yourself. So the message here is that the first lecture will be today at 10:15 to 1300 in this particular room. After the lectures, I will usually also write a message of where we are in the curriculum, what actually we have, which chapters or sub-chapters we have presented. Some very short message here after each lecture, and also some other relevant messages will be uploaded here. Well, this is my version, which also show the participants, and your version will probably be a bit different here, but you will have the documents, where you can find some curriculum and also some other information. Innlevering means the hand in, so you can hand in your assignments here on Fronter. And also there is an opportunity to have a discussion forum or some chat. If we now go into the documents folder, you can see that here we have several other subfolders. We have the two course information files here. I think they are also placed in the curriculum folder. This should be public available also for those who are not signed up for the course. And here in the curriculum we have these two information files, which I will come back to in a short while, and also 3 documents here, which is a part of the curriculum in the course. The curriculum is one textbook and the specified chapters in that textbook, plus these 3 lecture notes here, induction proofs, and 2 PowerPoint files regarding Lingo, which is optimization software, which we'll come back to later in the course. We can also see the lecture notes here, where a PowerPoint file for chapter 2 regarding forecasting, which is the first part, while chapter 1 in the textbook is not defined as the curriculum. So this is the first part in the textbook, which is the curriculum, and I will use some of these PowerPoint slides in the lectures. So this PowerPoint files here for chapter 2, 3 and so on will be uploaded in Fronter before the lectures, where I will present the content of these chapters. Also assignments, nothing there yet, but when I will also come back in a short while to the assignments, the number of assignments and delivery dates and so on, and then the problem description will be uploaded to this folder in Fronter. We can also solution files, nothing should be there yet, but here also some solution for the assignments and so on will be uploaded. Earlier exams, we have the 3 last year's exam of this course given here. Later I will also upload a solution or a suggested solution for these exams, but that will be at the end of the course, so you should as soon as possible try to look at these exams. There will be problems on different parts of the curriculum. First part will be a typical forecasting problem, and also some induction problem, which we will present today. So you can see here and also see how the problems are well, which type of problems you can expect to get on your exam, because the curriculum will be more or less the same for the last 3 years. And also you can try to solve the problems yourself, at least try to look at the problems and think how you would try to solve these. But as mentioned, I will publish a solution, and also maybe if time, we'll go through the solution on some of these exams at some of the latest lecture in the course. Also very important, try to look at these room and get all the information which is will be published here. Also, some information will be sent out by email to the HI Molde or the stud.himolde.no address you have. For example, some results on your assignments is typically sent out to this address. So you should also check this email address, even if you use another email address as your private email. Usually, you should also check this stud.himolde.no address, because some information could be sent out there. So, go back to the course information document, which is also uploaded here. I mean, this one, it's open here, and yeah, since you're here, you have already found out that the lectures are on Tuesday at 10:15 in this room. This is my contact information office, just over in the section where the professional personnel have offices, not very far from this room. Phone, both mobile and office phone, and also email and some homepage here. The literature is in particular this book, Production and Operations Analysis. It looks like this, and is sold at the Odin bookstore. And yeah, 6th edition from 2009, and the author is Stephen Namias. And the curriculum is also defined here in detail, which subchapters of the book is a part of the curriculum in the course. Some of the other could be read. Chapter 1 and also the first subchapters of chapters 2 can be read as some kind of relevant basic information, but you will not have directly questions regarding that content on your exam. But this is the defined curriculum, which is shown here. And in addition to the book, you will have this lecture note, which I have just shown, were uploaded in Fronter. Also, a bit later in the course, you will have to use some kind of optimization software to solve optimization problems, find the exact optimal solution. Given some information, you should be able to find the exact optimal solution of how much to order, for example, and when to order, which is a typical logistic problems, and also an optimization problem. And then we have several types of optimization softwares. We will use this Lingo system, which is produced by the Lindo company. And you can get a free trial version downloaded from this page here. I think at least it should be installed on the computers in the computer labs here at the college. Well, at least they will be installed, so I will have to check if they are installed already. The Fronter, as we just have seen, used as the standard communication between lecturers and students. There are mandatory assignments. There will be 3. In addition to the lecture and the final examination, we have 3 assignments. The first one is a pass or fail assignment. Will be presented next Tuesday, very early in the course, and you will have 2 weeks before delivery. And that 2 second will also be graded and will be count for 10% each of the final grade of the course. So if you have a grade, the grades will be in percentage. So if you, for example, get 90% on the first assignment, you have to multiply by 10%, which means 9, and then you get 80% on the second one, or this is of course the second. The first is the pass or fail assignment, and then it will be like this. And then if you get 70 on your final exam, you have to multiply that by 8. which should be 56. And then yeah, and then you have to add these together, which means 64, 73, which then will be the final percentage, which will be converted to the final grade as letters A, B, C, D, E, or F. So this is the way the grading and the evaluation of the course will be found by using the two last assignments of 10% and the final exam of 80% to find the final grade. Yeah, we can just also go through the details here. The assignment should be submitted, preferably in groups of 2 to 4 students, but if you want to do it yourself, it can be possible. Then just send me a very short application and to get permission to submit by yourself. But preferably you should work in groups of 2 to 4 students. And then, yeah, assignment will usually be presented within a 3-week limit before delivery. I think the second one at least is 2 weeks before. No, the first one 2 weeks before. And each assignment will constitute of 10% of the final grade, and the exam will be on December the 9th from 9 to 14 and will count for 80% of the final grade. And below in this document we will also have the list of the curriculum with the exact chapter numbers and the chapter titles, which is reference to the textbook Production and Operation Analysis by Namias. Yeah, also we talked about the only a few more words on the optimization software here. Lingo. There are different types of optimization software. You might have heard of the Cplex system, which uses a language, a programming language called Ample. Another one is Express. There are lots of others, and in the those of you who takes the operation analysis, the Buck 350 course, will, as far as I know, use the solver, which is a part of the Excel spreadsheet program. So it's also possible to use the solver in Excel or any other optimizer, but in this course, in the examples and so on, we will use the Lingo system because this optimizer is very close to the mathematical formulation, and as a part of the curriculum in this course, you should be able to read and understand the mathematical formulation of these types of optimization problems. So, yeah, let's go to the other document here. Lecture plan, which shows a bit more in detail. And this is, of course, a tentative lecture plan. There will be changes. Maybe I will go a bit further than this one. This is some today, introduction and practical information, which I'm giving now. Induction, which is the first part of the curriculum, and chapter 2.6, which is the first chapter or subchapter in the book, which is part of the curriculum. And then the exact limits between the subchapters and the lectures here is not very fixed. So maybe I can continue a bit here if I finish before time on that chapter and then continue on 2.7 and so on. But this is some kind of tentative, a rough schedule of the lecture plan. As we see here, next Tuesday, present assignment number 1. Then 2 weeks later, this should be delivered, and then assignment number 2 should be presented. And then September 24th, we will have a guest lecture from Harald Høm, which comes from the University of Wismar, and he will talk about theory and practice of vehicle routing optimization, which is kind of relevant to this course here. Vehicle routing scheduling, how to get the best routes of a vehicle which should visit a certain number of customers. And then we can see later here, we'll also present the solutions for the assignments. Here we have actually 4 weeks because of this guest lecture, so we have 4 weeks between the presentation and the delivery of assignment 2, and then 3 weeks of assignment 3 here. Hopefully we will finish the curriculum here in November 19th, and the last lecture could be used for repetition and problem solving. So, also, I showed the textbook here, Production and Operation Analysis. We'll say a few words about the content here, because it's the chapters will follow some kind of logic. It will start with the forecasting. The forecasting part, and then it will if we see here, chapter 2, forecasting, then we will continue with aggregate planning. Forecasting is of course important to try to figure out how much will the demand be for the coming periods. And then when you have a forecast or an idea of what you should actually, what is the demand, what should you produce, or what will you sell for the coming periods, you have to make an aggregate plan. Which is defined in chapter 3, aggregate planning. And here in this supplement to this chapter, you also have the introduction to linear programming, which we have talked about, is an optimization problem, which then should be solved by using an optimizer, or can be solved by using an optimizer. You will also learn some other techniques. Then the next step is inventory control. You have a forecast and you have a plan of how much the demand or the production will be or should be. Then you have to plan your inventory. And we have also here several ways, several models of planning inventory. The simplest is usually what we call the inventory control, subject to known demand, when you know the exact demand. According to the forecast, or in some industries, this is easy, that you know you have orders for several months in advance, for example. Then you know the exact demands for the coming periods, and you can make some plans according to the known demand. But what is probably much more happens much more often is that you have inventory control subject to uncertain demand. You make a forecast, but there are some uncertainty that you think that this will be the demand, but you don't know, because there will always be some kind of variation. And this will then need some other types of model than we use in chapter 4, which is according to the known or certain demand. Next step, or next in this hierarchy, you have the next level after inventory control. You have the production control system. And we have the two main types here, the push and pull system. We will mainly here focus on the MRP, material requirements planning. When you have a forecast, you have an aggregate plan, and you have some kind of inventory control policy. Then you can make up a control system regarding the material requirement planning, which is called called a push system. You have a plan and you make up the production according to that particular plan. What you also probably have heard of is the JIT, the just-in-time system, which is a part of some kind of opposite or another type of production control system, which is more based on the pull theory. When you have an order, you should pull all the materials and you should start production of components at that time when you know that you actually have sold the product. So these are two different types of philosophies that will to some extent will can be well, to some extent can be combined, but also in its extreme form they are opposite. MRP, make production according to a given plan, and the just-in-time, make production when you actually have an order and you have to pull the components and all the what you need for production when you actually have this order. We will focus here because most models are based on the planning system, the push system, MRP, but we will also, well, give a few words on the just-in-time system. And then at last, chapter 8, operations scheduling, which is the scheduling of job when you have been through all these other levels here. You have to plan in details on the shop floor what jobs to perform and which sequence to perform the jobs. So this is the curriculum, and then in addition we have this induction, which I will now start to present in a very short while, and also the 2 lecture notes regarding lingo. Lingo, the lecture notes will go specific into use of the lingo system, but the mathematical models will be shown in some of the sub-chapters here, and in particular the linear programming sub-chapter, which is at the end of chapter 3. Okay, I think that was enough information. Of course, if you have any questions or comments, you should contact me. If you have any questions now, I can try to answer them. Otherwise, it's just to send me an email or come to my office, and then I will try to answer as good as possible. So, let's now start on the induction part. And here we have this lecture note from 2006, originally by Elizabeth Staple, and now rewritten and adapted to LaTeX by Kjetil Haugen, which is now the pro-rector here at this college, and also taught a similar course as this earlier in 2006. So, mathematical proofs in general, and induction proof in particular, this is a part of the curriculum in this course. And here we have to prove a statement or a formula and find out, is this particular statement correct? Can we prove it mathematically? The textbook shows proofs of several of the formulas which is used. And I will not go very much into details of all the mathematical proofs. Not normally. I will start with this induction proof, so you should have an idea of this type of mathematical proofs. Some of the other proofs are more complex, use some other types of mathematics. And in this course, I will not, as mentioned, go very much into details of the other types of proof, but if you continue on the master studies, you will have another course, which is now called Inventory Theory, LOG502. And then you usually will have to give some more details and also need to understand and maybe also need to perform proofs to make sure that a given formula is correct. The proofs are essential when trying to find a model or formula which is valid for a problem. And even if a formula in your thoughts seems to behave correctly, only a mathematical proof can tell whether it is correct or not. And of course, if it's not, then a decision based on incorrect information can be go completely wrong. So here, to make sure that the formulas, the calculations you are doing, that they are actually mathematically correct, can be very relevant in a real world problem situation. And the induction part, which we will see here, is then one example on these types of mathematical proofs, and this is a part of the curriculum in this course. The idea of induction, it's based on 3 steps, or actually 4. The first is what we call here the thing you want to prove, which is also called the hypothesis. And according to an hypothesis, which is now step 1, let's call it that, you are given a formula or given a statement, and you should actually prove that one. Find out, is this statement, is this formula correct? Then the second step, which here is called the beginning step, usually start with n equal to 1, the lowest number, maybe also equal to 0, sometimes another number. But here, then step number 2 is called the initial or the beginning step. And the idea among these induction, and these induction proofs are used on integer numbers, 1, 2, 3, and so on, positive numbers, or eventually start by 0, but not negative and not fractions. So you start with the smallest case in the initial step, and if you know that this one is correct, then you can assume that this formula or this statement is correct for a given value, and you should try to see what happens if you increase by 1. So here, the next step will be the assumption. If the beginning or the initial step is correct, then we can assume that if n is equal to k, this will also be correct. I will show an example on this in the next lesson in 15 minutes. But then the assumption step will be the next part here. And after the assumption, you will try what we now call the induction part, the induction step, which is to increase by 1 according to the assumption here. So we start with a hypothesis. We check the initial step. If the initial step is correct, we can assume that, let's then say n equal to 1. Then we can assume that n equal to 1 given number, not necessary, not actually specified here, but 1 given number k is correct. And then the induction part of the proof will then be n equal to k plus 1. Try to increase by 1 from the assumption step. Which means if we can prove that this formula is correct on the initial step, n equal to 1, we can assume that n equal to k is correct, and then we have to check, is the statement or formula still valid if we increase by 1? And if we can prove that, we know that the hypothesis is correct. Because then, if 1 is correct, the induction will show that k plus 1, 1 plus 1 equal to 2, will also be correct. When we know that 2 is correct, 2 plus 1 will also be correct, and so on. We can continue into, well, eternity or forever, because this will still be correct if we increase by 1 here. Fourth step of induction: hypothesis, find a statement. Initial step, check for the lowest possible value. Then the assumption, assume that it is correct for a given number, and by induction, step 4, prove that it is still correct if we increase by 1. So, let's, before we take the break, have a look at one small example. We'll see several examples on this before we continue to the forecasting part. But now, let's now have an hypothesis that on step 1 here, the hypothesis is someone will claim that they know a formula for the sum of the positive, or the series of the positive integers. 1 plus 2 plus 3 plus up to a given number n, and someone claims that this sum can be expressed by the formula n multiplied by n plus 1 divided by 2. And if n is equal to 6, this will be 1 plus 2 plus 3 plus 4 plus 5 plus 6, and this should, in that case, be equal to 6 multiplied by 6 plus 1, 7, divided by 2. We should now use induction to prove or check whether this formula is correct or not. Okay, it's 2 minutes to 11, so I think we take a break, continue 11:15, and then I will go into details of this. But you can, in the break, if you want, try to check whether this is correct. Find the initial, check the initial step or the initial condition. Assume that it's correct for a given number k, and then try to increase by 1. Okay, we'll take a break and meet in 15 minutes.